The diagram is a speed time graph of an object which decelerates uniformly from a speed of 50 meters per second to a speed of 30 meters per second in 20 seconds. It further decelerates uniformly for 10 seconds until it comes to rest. Part A, find the speed when t is equal to 5 seconds. We need to answer A, and in A we are tasked to find the speed when time is equal to 5 seconds. So let us assume that this is the 5-second mark, right? So if we extrapolate, this will be the point. And another extrapolation, we will get y. So this is the y. And y, we are using y to represent the speed when time is equal to 5 seconds. Now the first point we should appreciate is the gradient of a speed time graph gives us acceleration. But in this case, of course, it's deceleration. So if we task ourselves to calculate the deceleration from this point to this point using the gradient of the speed time graph, this means that at this point, the coordinates are, putting the x-axis coordinate first, it's 0, 50. Then at this point, it will be 20, 30. So our acceleration or deceleration, to be more specific, so the deceleration will be equal to the gradient of our speed time graph. And the points we are dealing with are 0, 50 and 20, 30. So now considering the gradient, this will be equal to a change in y over a change in x. We come back here and we say this is our x1, y1, and this is our x2, y2. This means that the change in y is actually y2 minus y1 over the change in x, it's x2 minus x1. What is y2? y2 is 30. Subtracting what is y1, which is 50, dividing by our x2 is 20, subtracting our x1, which is 0. Here we are going to find 30 minus 50 being minus 20, divided by 20 minus 0, which is 20. So the deceleration is minus 1 meters per second squared. This is the gradient here. Now, having done this, what we actually want to find is the speed when time is equal to 5 seconds. And here is how we are going to do it. We found out that the deceleration we calculated was equal to minus 1 meters per second squared. And this deceleration is actually the gradient of this line from this point where the x-axis is 0 until this point where the x-axis is actually 20. Now we know that this point will be, the coordinates here are going to be, putting the x-axis first, it will be 5, and the y-axis, it will be y. We are using y to represent the speed when time is equal to 5 seconds. So maybe let us write it here. Let y be the speed when t is equal to 5 seconds, right? We know that this is a straight line from this blue dot to this blue dot. Forgive me if it's not blue, I'm actually colorblind. But this is a straight line. And for a straight line, the gradient is a constant. So if the gradient is a constant, we can actually try to find the gradient using these 2 points. The gradient should still be minus 1, because for a straight line, the gradient is constant. So the points we are now going to use to find our gradient, they are, let us use 0, 50 and 5y. So deceleration, which is equal to the gradient of the line or the curve, will in this case be equal to. Now let us assign this as x1 and y1, this as x2 and y2. We know that gradient is a change in y, delta y over delta x. This is equal to y2 minus y1 over x2 minus x1. So this is equal to, what is y2? y2 is y minus y1, which is 50, over what is x2? x2 is 5 minus x1, which is 0. And this is going to be equal to minus 1, as we determined when we actually found the gradient of this line, which is the deceleration of the body from the time when the speed was 50 meters per second to the time when the speed was 30 meters per second. So this would then be equal to y minus 50 over 5 from 5 minus 0 is equal to minus 1. To solve this, we are going to clear the fractions. So we multiply this side with 5 and do the same here. So 5 cancels out 5. We remain with y minus 50 is equal to minus 1 times 5, it's minus 5. So y is equal to minus 5 plus 50, plus, because minus 50 crossed over the equal sign and it changes its sign. This is minus 5 plus 50, which is the same as 50 minus 5 is actually 45 meters per second. So the speed when time is equals to 5 seconds is 45 meters per second. So what did we do for A? Because I feel my explanation is not as clear as I intended. So to summarize what we did for A, number 1, we know that the gradient of a speed time graph gives us the acceleration or deceleration of the body. So from this point where our speed is 50 meters per second to this point where the speed is now 30 meters per second, this straight line, if we find its gradient, the gradient is going to tell us the deceleration of the body from the time the speed was 50 meters per second to the time the speed was 30 meters per second. The uniform deceleration, as we are told in our question, which reads, the diagram is a speed time graph of an object which decelerates uniformly from a speed of 50 meters per second to a speed of 30 meters per second in 20 seconds. So the uniform deceleration is actually given by calculating the gradient. The uniform deceleration is given by calculating the gradient of the line from the point time is 0 to the point our time is 20 seconds. After doing this, we now determined the coordinates of the point where our time is equal to 5 seconds. We determined the coordinates of the point where our time is equal to 5 seconds, and our answer was actually 5. Then y. Y is representing the unknown speed, or the speed which is asked in part A. After doing this, identifying the coordinates of the point where time is equal to 5 seconds, what we then did was, using the uniform deceleration we calculated, which was minus 1 meters per second squared, we then determined what is the value of the unknown y, which is the speed we are asked to calculate in part A. And we found out that the speed is 45 meters per second. So this is how we calculated the speed when the time is equal to 5 seconds. Let us now go over to part B. Our part B says calculate the item 1 acceleration of the object during the last 10 seconds. So we need to identify the last 10 seconds, which are these ones. These are the last 10 seconds from this point to this point. We need to find the acceleration of the object during the last 10 seconds. So we are going to use two methods. Method number 1, we are going to calculate the gradient of the line. From the point our time is 20 seconds to the point our time is 30 seconds. Remember, we already said that the gradient of the speed time graph gives us the acceleration of the body. So that being said, let us calculate the gradient. We already have the point here. We identified that this point is 2030. We quoted the x-axis, which is 20, and the y-axis, which is 30. What then is this point? This point is going to be 30, 0. Why 30, 0? The x-axis or the x-coordinate is 30, and the corresponding y-coordinate is 0. So these are the points we are going to use. We are going to use 2030 and 30, 0. Then let us assign this to be x1, y1, x2, y2. The question says we should calculate the acceleration. So let us say the acceleration is equal to the gradient, which is given by delta y over delta x. And we know that delta y over delta x, the change in y is y2 minus y1 over the change in x, it's x2 minus x1. So this is equal to, what is y2? y2 is 0 minus y1, which is 30, over what is x2? x2 is 30, subtracting x1, which is 20. This is going to give us 0 minus 30, that's minus 30, over 30 minus 20, that is 10. We are going to find minus 3 meters per second squared. So the acceleration of the object during the last 10 seconds, it's minus 3 meters per second squared. So instead of saying the acceleration of the object, the question could as well ask, calculate the deceleration of the object. Actually, the word deceleration is more suitable. The word deceleration is more suited for B part 1 of that question. But in mathematics, the difference between acceleration and deceleration is not stressed on. We now need to introduce our method number 2. And in this method, we are going to be using the formula. What is the formula of acceleration? Acceleration is equal to final velocity minus initial velocity over time. So what is the final velocity? The final velocity is this point. This point is the final velocity, which is actually 0. So the final velocity is 0, subtracting what is the initial velocity. The initial velocity is this point, because remember, it's the last 10 seconds. It's the last 10 seconds on our speed time graph, which is represented from this point where time is close to 20 and this point where time is equal to 30. So our initial velocity, it's actually 30 meters per second. Then what is the time? As specified in our question, the time is 10. So if we say 0 minus 30, we are going to find minus 30 divided by 10. We are going to find minus 3 meters per second squared. So as you can see, the answer we got when we calculated the gradient of the speed time graph as a way of finding the acceleration of the object was minus 3 meters per second. When we used the formula, acceleration is equal to final velocity minus initial velocity over time. Again, our answer was minus 3 meters per second squared. So it is up to you. The ball is in your hands. Whether choose to use the method of calculating the gradient or to use the method of the formula. Let us now go over to part 2 of our question. Calculate the distance traveled during the 30 seconds. How do we calculate the distance? We should know that the distance is given by the area under the speed time graph. So the area under the speed time graph is the distance. The area we are referring to is this one. This whole area is the one which is going to give us the distance of the body during the 30 seconds. So how do we calculate the distance? We can divide this shape into 3 parts. We then call this A, then B, then C. So in order for us to find the distance, which is the area under the graph, so distance, it's equal to area under the graph, and this is equal to the area of A plus the area of B plus the area of C. What is the area of A? So A is actually a rectangle, which is given by, so the area is given by length times width, plus what is the area of B? B is a triangle, it's half base times height, plus C is also a triangle, so it's half base times height. So this is going to be equal to, what is the length? The length is 20, right? The distance from this point to this point, it's 20. So the length of 20 multiplying the width of 30 plus half, what is the base? The base here is actually 20, multiplying a height of, the height is from this point to this point, so it's 50 minus 30, which is also 20, plus half of, what is the base? The base here is 30 minus 20, which is 10, and what is the height? The height is 30, because the height is from this point to this point. This then is equal to, let us say 20 times 30, it's 0, 3 times 0, it's 0, then 3 times 2, that's 6. So here it's 600 plus, then 2 into 2, it's 1, 2 into 2, it's 1. So it's now 10 times 20, which is 200, plus, then the half of 30, it's 15. 2 into 30, it's 15. 15 times 10, that's 150. If we add this, it will be 0, 5, then 6, 7, 8, 9. So it's 950 meters. This is the distance traveled during the 30 seconds. So this is how we find or calculate the distance traveled during the 30 seconds. You can also consider this trapezium as your shape A, and then this triangle is your shape B. So your distance, it's going to be equal to the area under the speed time graph, which is given by the area of a trapezium, which is half of A plus B times height, adding the area of B, which is half of base times height. So this is the area A plus area B. Now what is A? Like this small letter A. So this small letter A is going to be from this point to this point, which is actually 20. So it's 20 plus, what is B? B is from this point to this point, which is 30. Then we multiply rather with the height, which is from this point to this point, and it's 30. Then we add half of the base of this triangle. From this point to this point, it's 20. And the height of the triangle is 50 minus 30. So calculating here, we are going to say half of, dealing with what is in the brackets first, 20 plus 30, that is 50. Then multiplying 30 plus, then half of 20, it's 10. So 10 times 20 is 200. This is equal to, what is half of 50? That's 25. So we are going to multiply 25 times 30. Here it's 0. Then 3 times 5 is 15. 1. 3 times 2 is 6 plus 1, that's 7. So here we have 750, adding 200. And obviously, this is going to give us 950 meters. The same answer we got when we subdivided the speed time graph into 3 shapes. Now we only subdivided it into 2 shapes. What if we subdivide our shape into 2 shapes, which are shape A and shape B? So our shape A is this trapezium, and this triangle is now our shape B. So calculating this, our distance again is going to be given by the summation of area A and area B. So area A plus area B. We seek to find the answer 950 to prove our point that you can subdivide the speed time graph into different shapes. Our area A, it's half of A plus B times height, adding the area of B, which is half of base times height. This is equal to half of, what is A? So A is going to be from this point to this point, which is 30, plus what is B? B is from this point to this point, which is also 50. Then the height is this. This will be the height, the perpendicular distance between A and B, and the height is going to be 20. Added to half of, what is the base? The base is 10, and the height is from this point to this, so it's 30. Now calculating this, we are going to say 2 into 2, 1, 2 into 30, that's 15, 2 into 50, that's 25. Then the half of 30, that's 15. So this is equal to, what is 15 plus 25? 15 plus 25, 1, then it's 40 actually. So here we have 40 multiplying 20. Then we add this to 10 times 15, which is 150. What is 40 times 20? 40 times 20 is going to be equal to 800. Then we add 150. Again, we are going to get 950 meters. So I know there might be confusion as to what I really did here. What I did here was, if we have, for example, 4 plus 2 divided by 2, we can find this by adding first to get 4 plus 2, which is 6, divided by 2, and our answer will be 3. Or what we do is, this 2 becomes a factor which gets into both 4 and 2. So 2 into 2 becomes 1, 2 into 4 becomes 2, and 2 into 2 becomes 1. 2 plus 1 also becomes 3. So this rather, what I did here is a special way of solving problems where we have a fraction multiplied into a bracket which contains either 2 numbers adding or 2 numbers subtracting. Sum up what we have just learned. The most important facts are, firstly, that acceleration is given by the gradient of the velocity time graph, which can also be called the speed time graph. Since velocity and time, though different, in mathematics, the difference is not as much recognized. Then point number 2, we learned that the distance is given by area under the speed time graph. So these are the two main facts which we used to solve our questions. Thank you.